Hello and welcome to this lecture. My name is Miracle Chibuzor Marcel, and I'm the founder and the director of the Pan-African Citizen Science e-Laboratory. So today we are going to be studying the space station. The space station, okay? Remember, I didn't call it International Space Station because International Space Station is one of the many space stations we have had in the past. So this is just part one, the space station part one. Please do not mind me. The picture right there is the International Space Station, quite all right. But like I said before, the International Space Station or ISS is just one of the many space stations that we've had in the past. So the space station part one, that's going to be part two, part three, until we cover the whole topic about the space station. So at the end of this lesson, you, the learner, should be able to know the meaning of a space station. You should be able to know the meaning. Okay? And then, number two, you should be able to not just know the meaning, you should be able to differentiate it between uh, between between it and satellites because we have a lot of similarities and also spacecrafts because there's a lot of similarities. Okay, have to differentiate between space stations and satellites and spacecraft. Then you, the learner, should be able to explain why humans built the space stations. We have been building it back in the days. Okay, so why we build it. And remember, the ISS is going to be retired, and uh, we are planning to build a lunar gateway that'll be orbiting the moon. So why do we build these things? Why do we build the space station? Is it a waste of money? Is it for fun? Is it because of too much money? Is it because countries have too much money and they want to spend money? Not exactly. There's a reason, which is very important. So you should be able to explain why humans build space station. And lastly, you should be able to identify and describe the basic features of a space station. So, by the way, this lecture is sponsored by the Free Astro Science Group. You can check their website, freeastroscience.com, igniting curiosity. So, introduction. Meaning, what is a space station? A space station is like a large spacecraft that stays in orbit around Earth or another celestial body where humans can live, work for long periods of time. I said a space station is like a large spacecraft that stays in orbit around Earth or another celestial body where humans can live and work for a long period of time. So, first of all, what is a spacecraft first? Remember when I was talking about the Artemis programs, I described the spacecraft as a vehicle that takes astronauts or robots from Earth to another planet or from Earth to another celestial object like the moon. Okay, when astronauts want to go to the moon, they enter inside the spacecraft. When they want to go to the International Space Station, they board a spacecraft. So, and I said a space station is like it. Okay, but a space station is larger. Okay, and it is meant for humans, astronauts, to live there and work there for a long period of time. Therefore, space stations are different from spacecrafts and satellites. And I'm going to explain that in details. So if you look at this is a satellite, typical satellite. This is our ISS or just call it space station, and this is a spacecraft. Now, if you look at these three, you might think that they are the same, but they are not the same. Okay, and I'm going to explain the differences. For a satellite, for a satellite, a satellite is simply an object that orbits a planet. Okay, it could be a natural satellite like the moon. So here is the moon, here is Earth. Moon is orbiting Earth. This picture was taken by the Artemis 2 astronauts. Okay, so by the Artemis 2 astronauts, then we have artificial satellites, which is the artificial one. Okay, so these are just satellites. We have examples of these artificial satellites are communication satellites. We have weather satellites. So, but the key idea of a satellite is that a satellite do not carry human beings. They do not carry human beings. So engrave that at the back of your mind. Then we have spacecraft. So a spacecraft is designed to carry humans or robots to deep space. Examples are the Orion spacecraft, like you can have it here. This is the Orion spacecraft. So here is the Crew Dragon spacecraft by SpaceX. Okay, so the key idea is that a spacecraft are usually for transport. They transport astronauts from one place to another in space. So, and they're just for temporary stay, just like a vehicle. So it's not long. It is not meant for long stay. So just temporal. Take astronauts from Earth to the moon and back, or take astronauts to the ISS and back. So that is just the spacecraft for you. Then we have the space station, which is the topic of today. The space station is then a special type of spacecraft designed for living in space for weeks, months, and even years. So I hope I've been able to explain the difference between these three. So in summary, a satellite is simply like a camera in space. We use it for communication, we use it for observations, we use it for monitoring weather. So just satellites, we use it for security. Okay, we use it for military. Then we have a spacecraft is like a car. Your car, you enter your car to go to places. Okay, from to go to places. Then a space station is just like a house. It's just like a house where you live. Okay, so you see they are different. I hope I've been able to make the difference clear. So they are not the same thing. Take note of that. Now, why do humans build space stations? Why do humans build space stations? You have to understand the reason. Why we built it is not because of you know being extra wealthy, want to spend money. No, not at all. We didn't do it because we have solved all the problems on Earth and we want to go to space. No, we built it for a very special reason, and I'm just going to mention some few of them. So number one is scientific research. Very important, scientific research, because space provides conditions Earth cannot provide for us. Okay, for instance, on Earth, gravity affects literally everything we do. Everything. For instance, how liquids flow, how flames burn, and even how our bodies function. Okay, so if you take out gravity, so if you take out or maybe try to silence it using microgravity, okay, because you can even on the ISS there's still gravity there, but you can silence it a little bit. You can reduce its effect using microgravity through free fall. Okay, so in space, things behave differently. Okay, because of microgravity. So that is why space stations are also called microgravity laboratories. Now, what makes space station special? What makes it special is that scientists can study pure physical processes, okay, without gravity interfering, okay, you know, microgravity trying to, silence it, okay, trying to, reduce its effects, okay. Then space stations, you know, helps us to perform experiments that are impossible on Earth, okay. So they make experiments that are impossible to be possible. And I'm going to explain that, especially in medicine. There's some experiments in medicine that are impossible on Earth, but that are possible in space. So, so it is now directly connected to our health. So this is the why it is very important. Scientific research. Okay. Now, so let me explain some examples of these experiments. I'm just going to be just a few of them. Some of these experiments that are being done on space stations. For instance, behavior of fluids. The behavior of fluids. You know, fluids like water. Okay, water is a fluid. Okay, fluid like water in space. I mean, the microgravity of space. They form floating balls instead of flowing downwards like this. Like, okay, let me just show you. This is how water behave. All of us are aware of that. Okay, water flows straight. So we bathe with water. So when we are bathing with water, it just flows down. Okay, it just flows down. It just flows, flows, flows. Okay, but in space, okay, it doesn't behave that way anymore. It forms a floating ball. So I just want you to watch this video. For that. Now, if you look at this water, okay, it behaves like water droplets when it is falling down, but you know, it looks, it looks more stable. Okay, unlike what we have on Earth, you have this water flowing. Okay, and the answer is because of what we call surface tension. Surface tension is this force that acts on the surface of liquids, including water, that makes them to behave like stretched elastic film. Okay, so the reason why we do not experience this on Earth is because of gravity. Okay, so on Earth, gravity overpowers this surface tension, okay, causing water to flow. But in the microgravity condition of the ISS, sorry, of space, water floats in perfect sphere. So that is why we see that. That is why it is like that. So these are some of the experiments that are being performed in space station. Very nice experiment. So another wonderful experiment being performed at the ISS is the behavior of flames of fire. Okay, on Earth, this is how flames of fire behave. Okay, okay, and here is the behavior of flames of fire in space. It becomes spherical instead of rising upwards like we have it on Earth. And the reason is because of air. Air supports burning, okay? Air supports burning. So as air that is closer to here, when they are used up, they become hot and they go up. The cooler air comes down, okay? So that is, it is giving convection current, right? Remember that? So that is why it gives fire this teardrop shape that we see, okay? But in space, okay, there's no direction. Where we have microgravity, okay, there's no sense of up and down, okay. So there is technically no, this gravity around. So it is not going to exhibit this buoyancy, okay. So how it burns is that oxygen reach the fire by only diffusion. So the flame spread evenly in all directions, creating this sphere instead of a teardrop shape that we usually know it for. So I'm going to show you some examples. So now, why does experimenting with fire in space really matter? I mean, fire. Why are we doing that? Is it are we playing games? Is that why we built the International Space Station? And the answer is that it matters. It matters because fire behaves strangely with different conditions. Okay? Remember that fire is humankind's oldest chemistry experiment. Back in the early days when doing evolution, when humans evolved to humans, okay, we were going about hunting for animals, we kill them, we eat them without even cooking them. Then we use their skin to make clothes to cover ourselves for warmth. Remember that, okay? Now, short after that, we discovered fire through friction, striking two stones, and from there we started using fire, okay, to cook. Okay, you can see that started using fire to cook. So fire is important because we use it to cook, and also engineers study burning to produce better internal combustion engines for cars, for rockets systems. Okay, so you see, fire is very important. Also, chemists use burning to study chemical reactions. So you can see this scientist, chemist, he's literally holding fire, but he's not being burnt. And probably have seen that before. So you see that fire, depending on the condition you are, around the fire, it can behave this way. Okay, so you see that fire behave differently, and most importantly, fire can consume. So you see, it's important. We use fire, for our daily activity. So if we do not manage fire very well, we can get consumed. So that is why studying it is very important and why it matters. So I want you to listen to this video to understand more about the fire experiment in space.
Fire is one of the most familiar things we know, but in space it behaves in ways that seem almost impossible. On Earth, flames rise because hot air moves upward and cold air rushes in to replace it. That's what makes fire flicker. But in zero gravity, that doesn't happen. There's no up, no down, and no direction for heat to move. Without gravity, flames don't rise. They float. They become soft, glowing spheres, hovering like tiny suns. Astronauts were amazed when they first saw this. A perfect orb of fire just hanging in space, calm and silent. Without convection, there's no flicker, no smoke trail, just a small, steady glow of blue. NASA scientists have been studying this strange behavior for decades aboard the International Space Station. They run experiments called FLEX, the Flame Extinguishment Experiment, where astronauts ignite small fuel droplets. In these tests, they discovered something truly unexpected. When a normal flame goes out, a new one can quietly keep burning. This invisible reaction is known as a cool flame. Cool flames burn at much lower temperatures, only a few hundred degrees Celsius. They don't shine brightly, but the chemistry continues. In fact, a cool flame can keep consuming fuel without producing light, almost like fire's ghost. Here on Earth, gravity and air currents make these flames unstable. They appear for milliseconds and vanish. But in space, cool flames are smooth and steady. They hover in perfect balance, letting scientists watch every detail. These discoveries could revolutionize how we understand combustion, and maybe even how we power engines in the future. Imagine cleaner engines, spacecraft propulsion, or even sustainable energy, all inspired by flames in zero gravity. But studying fire in space also comes with danger. Without gravity, smoke and heat don't rise. They just float. That means even a small spark could fill a spacecraft with toxic fumes in seconds. That's why every flame experiment aboard the ISS happens under strict control inside sealed glass chambers. For astronauts, every spark is both beauty and risk. Still, they keep studying it, because every flame tells a story about how nature behaves when you remove gravity. It's a story about chemistry, physics, and the resilience of energy itself. And beyond science, there's something poetic about it. Fire, so familiar on Earth, transforms into something alien in space, a calm, floating sphere. No sound, no direction, just light, softly suspended in silence. It's like watching the essence of fire stripped down to its purest form. Cool flames remind us that even the simplest things can reveal new mysteries when we see them differently. They show that science isn't just about control, it's about curiosity. Each flame experiment in orbit brings us closer to understanding how energy works across the universe. And what we learn up there could help us down here. From efficient engines to cleaner fuels, from ancient torches to rocket thrusters, fire has always followed us. Even in space, it adapts, changing shape, temperature, and color, but never disappearing. It's a symbol of life and discovery, reminding us that energy finds a way to survive anywhere, even in the cold vacuum of space. So next time you light a candle, imagine what it would look like in orbit, a tiny blue sun floating silently before your eyes. Cool flames aren't just science, they're living art, proof that the universe still has secrets left to share. If you loved this journey into the strange beauty of space fire, subscribe for more. There's so much more to explore, and this is only the beginning.
This is only the beginning. So that is very, very interesting to know. So now let us move on to other kinds of experiment being performed. Research or experiment being performed on the ISS. Okay, so on the ISS, we study the behavior of crystals like proteins. Proteins on Earth are okay. They grow, but they do better. They do much better in space in space stations. Okay, so and that helps us in medicine. Okay, it has direct connection to health. So because it helps in the development of drugs that we use. So I'm not into medical line, so I may not be able to follow up all the details of the medical research going on the space station, but I'm going to play this video so that you can follow me to understand it. So
The International Space Station could help develop new and better drugs for people on Earth, thanks to protein crystal growth, or PCG, on board. Proteins perform vital roles in our bodies, but they can lead to disease if affected by a gene mutation or virus. To treat these diseases, scientists aim to develop medicines designed to bind to specific proteins in the body. To study and analyze the protein's precise shape, scientists grow proteins in the lab in their crystalline form. But where's the best place to grow protein crystals? Space. Protein crystals grow larger and more uniformly in microgravity than they do on Earth, inspiring drug companies and academic researchers to conduct hundreds of protein crystal growth experiments on the space station over the last 20 years. The results of this work on station hold extraordinary promise for the future of human healthcare. JAXA, the Japan Aerospace Exploration Agency, has led significant experiments uncovering potential treatments for Duchenne muscular dystrophy, a currently incurable genetic disorder, and is developing drug formulations that can remain stable at room temperature, eliminating the need for refrigeration. PCG research into monoclonal antibodies has also shown the potential to shift drug delivery from intravenous methods to injections, significantly improving the quality of care and offering cost efficiency. Innovative research continues aboard the space station, from developing technology for membrane protein crystallization to finding new processes for growing high-quality crystals. With new and better protein crystals, the potential for future medical and scientific advancements is as far-reaching as the depths of space.
So that is all about the behavior of protein and the importance of the space station in the field of medicine. So now we study the changes of human body in space, okay, through while living in space stations, okay, because astronauts have reported, okay, bone loss, muscle weakening, okay, and the reason is because in space gravity doesn't pull on our body. Okay, gravity, it has been silenced. Let me just say, gravity has been frozen. It is there, but it is no longer active. Okay, we now have what we call microgravity. Okay, so in these conditions, our bones or human bones and muscles don't have to work as hard as they used to do on Earth. So this makes the bone to lose minerals and they become weak, and the muscles shrink and they get even weaker. So, however, to counter that, astronauts are required to regularly exercise their body to stop these changes. I mean, not to stop it, to mitigate it, okay, because it still happens. It still happens. So you can see the astronaut exercising. They are required to do this all the time. So now, in space, do you know we grow taller? We grow taller in space by 1 to 2 inches. Okay, and the reason is because without the gravity compressing our spine, the intervertebral disc expands. Okay, it expands temporarily, and that increases our height to about 1 to 2 inches. So you grow taller. Okay, you grow a little bit. That's 1 to 2 inches. Not much. Okay, so these are some of the amazing changes that undergo in our body while we are in space. So you see why it is important for us to study the behavior of the human body in space before we start even going to the moon or Mars or venturing in the stars. Because if you do not know these little details, it will cause fatalities in space exploration. So we are done with research. Okay, that is number of research, all the fire, all the fluids behavior, all the medical research are on the research. Okay, so number two reason uh, why space station is important is because we learn how to live in space. We learn how to live in space like as humans, because we humans are not naturally built for space. Space is not our natural habitat. Okay, so space stations help us to learn how to survive outside Earth. So while on it, we test the air systems for oxygen production. In fact, the oxygen systems we use in the hospitals today are as a result of the space station. of space exploration. Okay, the water recycling systems are the modern water recycling system. You know, the advanced ones is because of because of space station, because of space exploration in general. Okay, the food storage nutrition, storing food and preserving food is because of our knowledge of space station. So you see, there is an application. Whatever we uncover for space station has an application on Earth. You understand? Even the exercise routines performed by an astronaut is important. So to counter that, so we learn how to live in space. We learn how to live in space. Then the space station is important because it helps us to observe the Earth. Okay, so from space, astronauts can see Earth in ways we cannot see from the ground. You can even see what's going on there. I think that is tornado. You can't see that from the ground, can you? So you can only see that from space. Space station enables you to do that. Okay, so astronauts monitor weather conditions like hurricanes, storms, wildfires, okay, deforestations, ocean changes, so many. So they see everything from space, even volcanic eruptions. Okay? Oh, yeah. Even volcanic eruptions, the plume does not reach their high. So from there, they can literally see what's going on. So, number four importance of space station is that it, it fosters international cooperation. Look, this is a Russian astronaut, and these are other Western astronaut. And you see them, they are hugging themselves, they are happy being colleagues, they're not they didn't bring the fight to the space station. No, on the ground, these countries do not get along. Like Russia and European countries, there is current war in Ukraine right now and they don't get along. Okay? Okay, but in space they get along. So it fosters international cooperation. So you see that space is one of the few places where humanity can truly collaborate, can truly work as one. So you can see countries sharing knowledge, okay, sharing technology, and even sharing the cost of space exploration. Okay, so nations that have political differences, they work together, they will get along in space. So it fosters peace on Earth, space station. You see that? So I don't think there's anything on Earth that can do that. What can you tell me what on Earth can bring about this level of international cooperation? Not even the United Nations can bring this level of cooperation. But here you have it. You see, nations cooperating. Even the Artemis program, you see, nations cooperating. That is the wonders of the space station, the importance of the space station. So it helps to inspire children in STEM education. Okay, so you have this program we call the Amateur Radio on International Space Station that enables students all over the world, communicate with astronauts on the ISS. So you can see that. Okay, we call it the Amateur Radio on International Space Station. Okay, so students or kids are inspired. Okay, so seeing humans in space, feels so excited. Okay, so and students begin to ask important questions like how the rocket work, how can I become an astronaut? So these things, encourages them, inspires them to pursue careers in science, technology, engineering, and mathematics. So that is just I just mentioned four importance of is it four or five? Sorry, five importance of the International Space Station. So I'm gonna just go straight into the basic features of the space station. The basic features of the space station. So I didn't say ISS. I didn't say International Space Station. Although I'm just using it here because ISS is just one of the many space stations we've had in the past. Okay. So basic feature is that it's going to have an orbit. So space station is, space stations or even satellites are constantly falling around Earth. just like just like the moon, okay, that constantly falling. So, what is the idea behind this? I'm going to explain. So you have someone here throwing an object with a certain speed, certain initial speed, but it falls down to the ground when it gets to a particular maximum height. Okay. Now, if this person continues to throw this, let's just imagine here, this person is on the top, on the surface, continues to increase the speed. So you see that it's going to be reaching more and more distances because he is increasing the speed. Okay. Now there comes a particular speed. Okay, that when you throw it, you're going to give enough speed to that object that it will continue to move and it want to fall, but because of the speed that it possesses, it can no longer fall. So we call that orbit. So orbit. So objects in orbit are constantly falling, but they're not touching the ground. So that is how space station orbit. They are in orbit just like satellites. So you see that they are moving at very high speed. And the kind of thing that can give you this kind of speed is rockets. Rockets. Okay, that is why we launch with rockets. Okay, even guns cannot take you, cannot place an object in orbit. Okay, or even ballistic missiles. Ballistic missiles can just go up and just fall down, but to not attain orbit. Only rockets. You have to properly plan it, then you launch it. So you have the orbit. So another feature of the space station is microgravity. Inside the space station, astronaut you've seen that before. Astronauts feel like they are floating, and some people mistake it as, oh, they call it zero gravity. A lot of people make that mistake and call it zero gravity, but it is not true. Okay, because from the sea level to where you have the space station, typically at 400 kilometers above sea level. Okay, if you do the calculations, you can do the calculations here. If you do the calculation, you discover that at that height, gravity is as strong as is 90% as strong. So it is just like we have 9.8 on the surface of the Earth. Then at that height, 400 kilometers, we have 8.7, which is about 90% of what it used to be. So you see, it is not zero gravity. It is not zero gravity. It is called microgravity. The reason why, the reason why we have microgravity is because of what I explained here. What we call it is freely falling. It is freely falling. It is freely falling. Okay, we call it microgravity. Microgravity, not zero gravity. So objects inside the space station are in free fall. Okay, so let me use this simple physics thought experiment to explain it to you. You probably have experienced it. So here you have someone in an elevator that is not moving. So in this elevator, you have your normal weight, okay? But once elevator is going down at a particular speed, this is practical, okay? If you've been inside elevator before, you discover that you are feeling lesser of yourself. You are feeling lesser. Your weight becomes lesser and lesser because that elevator is going down at a particular speed. Okay, so if you allow the elevator to go up, you feel more of your weight. So I want you to understand what is going on here. So at this point, assuming that you are going down and you cut it off, you see that the elevator begins to fall freely. So you lose your reaction on the surface becomes zero. Okay, so you feel no weight. So even here on Earth, you can feel weightlessness. In fact, a falling object is said to be weightless. But the only disadvantage is that you have surface and you're going to crash land. Okay, but assuming that there's no surface, you just have to continue falling and falling. It's called microgravity, it's called free fall, it's called weightlessness. Okay, so that is exactly what astronauts experience on the ISS. So it's called microgravity, not zero gravity, and that is why water form this shape, and that is why fire burn like this. So another feature of the space station is that it's going to have life support systems. Okay, a space station must be able to keep astronauts alive, just like on Earth. Just look at this astronaut. They are in space station. I mean, in space station, probably in the ISS here. Okay, so but they're not wearing the astronaut suit. Okay, the reason is because the condition inside the space station is kept in the same condition just like on Earth. Okay, the only difference here is that they are in free fall, they are in microgravity. So, what are these systems? Number one is the oxygen system. So, the oxygen system, the astronaut breathe. Okay, that should be a system that that generates this oxygen. Okay, for the astronaut to breathe because it's important, and also to maintain the pressure there. Okay, then they also have the space station should also have a water recycling system. Okay, water is the space station, the ISS especially, is very efficient in doing that. It literally recycles everything. It recycles the water, the urine of the astronaut, even the moisture coming from their mouth and the nose of the astronaut. They are recycled. The water from their waste, they are recycled. Okay, so look at that. Okay, everything from their sweat is recycled. So the space station should have a temperature control systems because space is extremely hot and also extremely cold, depending. When it is hot is when it is out of the Earth's shadow. When it is cold is when it is inside Earth's shadow. Okay, so the temperature system should be able to regulate it so that to keep the temperature stable for the astronaut inside it. It also have some protections from protection against from these satellites should be able to shield the astronaut from these space debris. Satellites that are no longer functional, that have been destroyed, and also protect the astronaut from radiation, cosmic rays, solar wind. And so, space station should be able to protect them. Okay, the space station should there should be food. Okay, food supply. I think every 3 months, food is sent to the astronauts in space. I think every 3 months, food and other supplies are sent to them in space. And also, they produce waste from sachet, okay, from the foods, from the packages, and also from their human waste. When they want to dispose it, they discard it. So when the waste is falling, like this, when the waste is falling, they are falling at great speed. So when they enter Earth, they burn up. So they burn up in the atmosphere. So that is how they so there should be food and waste management system. There should be protection against radiation. There should be, temperature control. There should be water recycling system. There should be oxygen system to enable the astronaut stay alive, just like on Earth. So that will bring me to the end of my lecture today. If you have any questions, please post in the comment section. So I will bring in part 2 next time. Thank you.